Saran, and I welcome you all to the LIGO-India series, which is behind the scenes series, where we interview gravitational wave students and more. So today we have Nikhil Sarin, a PhD student from Monash University, who studies gamma rays and neutron stars and even gravitational wave astronomy. So I'm very excited to ask him many questions. And how are you doing, Nikhil?
I'm good, thank you. How about yourself?
Yeah, I'm good too. So are you ready for this interview?
Yep, absolutely.
So first of all, I would like to ask you, how would you describe your research to a high school student?
Um, I look at basically most massive explosions in the universe and in our entire universe, where some fraction of them produce this exotic object known as a neutron star. Now, a neutron star is this, compact thing, much like a black hole, but instead, slightly more massive. It's got a mass, more about the same as our sun, slightly more. So compact. It's about the same size as a small city, so about 10 kilometers. So there's a lot of interesting physics that happens when you put such a big mass into such a small space. And if you think about the density of a neutron star, a 1 gram of a neutron star would weigh about as much as um, the all of the humans on Earth combined. So it's really, really dense. 1 centimeter of a neutron star would weigh quite heavy. In some of the most massive explosions in the universe, you have these exotic objects form, and I look at these observations and try to figure out how these exotic objects behave and what we can learn about, our universe from them.
And that is very interesting. So just a follow-up question on that, like how often are these neutron star events, like when a star explodes, how often do you get a data like this? So how frequent it is?
So that's a great question. Somewhere in the universe, every 10 to 100 seconds or so, there's a neutron star merger happening. So there's two neutron stars that are in a binary, and that's what we see in gravitational waves. Unfortunately, the way LIGO is right now, how sensitive it is, it can't see all of them. But somewhere in the universe, every 10 to 100 seconds, there's a neutron star merger happening, and that'll
So
produce a LIGO signal, and that'll produce gamma ray burst, which is this massive explosion that we can see.
yes, so that's pretty like way too frequently. I did not knew that. Okay.
Yeah, pretty across the universe is pretty frequent, but we don't see it as often. In 2 years we've seen two of them.
My next question is, what was your biggest challenge, with respect to your research because of the pandemic?
Because of the pandemic, Australians weren't allowed to travel anywhere, and the pandemic happened at a time for me where I needed to go overseas to collaborate with other people so that I could get my next job. This made it, more difficult than it otherwise would have been, because I had to do everything over Zoom, which
Yeah.
was, that was difficult, with the time zones and everything like that. So yeah.
So my next question is,
Yeah,
even though
absolutely.
I think you might be biased to answer this, but let me still ask you, which waves would you prefer, electromagnetic waves or gravitational waves to study?
Okay, I think I'm gonna surprise you by saying that I prefer electromagnetic waves.
Okay, why is that?
So, why is that? Well, because I really like gravitational waves,
Yeah.
but I I just feel like there's more. At least the gravitational wave signals we see, at some level, we can explain them reasonably well. We can explain them, as being from either a merger of a black hole or a merger of a neutron star, binary neutron star, or binary black hole. At least the ones we see. Whereas the electromagnetic radiation we see from, the massive explosions of stars or gamma ray bursts and things like that, they're very difficult to explain the origin of them. We can explain some broad features of them, but what's really going down, what's the physics underneath them, it's pretty difficult. So that's why I find them more mysterious in a way, and
Yeah.
that's why I like them.
Yeah.
As a purely a medium though, as something for energy to travel through, gravitational waves are cooler. but the phenomena that exists in um, electromagnetic radiation for me is more interesting at the moment.
Okay, I did not knew that. That's cool. So, yeah, and that just made me curious. Like the wallpaper that is behind you, is that some type of gamma ray burst? Because I can see something is happening there, which kind of looks similar to the
That's
answer you were
right.
giving.
That's that's right. That's right. So the reason for this background is basically because I gave a talk this morning at a conference,
Okay.
and I was using this background as my talk background. So I just
Yeah.
decided to keep this as my virtual background.
Yeah.
So that's actually right. Maybe if I can get out of the way, it's possible to see the full thing.
Yeah.
It's in a way. So this material that you're seeing, that's the jet. This relativistic material,
Yeah.
and that's what's producing gamma rays in the first place. Yeah,
Yeah.
but not for 80-20-20 BLT, which was for some reason very weak.
Well, thank you for giving us, such in-depth understanding of what exactly it is. Even I personally did not knew it. Like this is something when it comes to gamma rays, so much like new research is being done, and astronomers don't have so many answers. Like what is going on? So this was very exciting. My next question is, what is your favorite space image by any space telescopes
What is
or
my favorite?
anything? Yes.
That's a good question. You caught me a little off guard there. I have never really thought very deeply about what's my absolute favorite. I can name a few. So I really like the image of the Hubble Deep Space image, which is
Yeah.
this image of all the galaxies, the Hubble image. Um, and another one I really like is Sagittarius A. I think. Well, actually, I'm going to change that answer. I'm going to say M87, the image of
Yeah.
the black hole. That's
Yeah.
more recent and apt.
Yeah.
Yes, I'm going to use that one.
Okay. Great.
But I think either the Hubble deep space image or the M87 black hole one so far.
Yeah, they both are very great, and I think some of the most famous images as well. So much hard work must have been gone through, like years and years of work, and that's why you're choosing those images. Like, it's not just about the beauty, but all the work that has
Yeah.
been gone so many years. Okay, my next question is, how did you got interested into astronomy?
I grew up in India, and at that time, I didn't really have any interest in astronomy. But I moved to New Zealand when I was 10 or so. Um, and there, I did high school there. And in high school, I had a teacher who I can't remember for certain if he worked at NASA or, did an internship at NASA or whatever. But for whatever reason, he came back to teach at that high school in New Zealand, and he was just the coolest teacher ever. So I was like, yeah, I want to become an astrophysicist, like this person apparently was for a little time.
Yeah,
And at the same time, I had a very close friend who was also interested in astrophysics and astronomy in general, and we both sort of pushed each other on to want to do astrophysics and astronomy, and we both have become PhD students, and now almost finished as well.
yeah. So it all goes back to the teacher that inspired you.
Pretty much, yeah. I think so.
Shout
That
out
that
to your
high school
teacher.
teacher, yeah, pretty much. Yeah, that's right. That's right.
So my next
Definitely.
question is, what was your reaction to the gravitational wave detection that was first, when it was first announced in 2016?
What was my reaction? Oh, I so this was really cool because 2016 was the first year I started doing. Sorry, 2015 was the first year I started doing proper astrophysics research, and that was at that time I was really interested in. I think because of Interstellar, maybe. I was really interested in accretion disks and black holes, like massive black holes,
Yeah,
and I wanted to do a project around that. And I hadn't really thought about gravitational waves so much. Um, and then in 2016, before, I think, or around the time that this was announced, I started my undergrad course in relativity and cosmology, and that was taught by my current supervisor, Paul Lasky, and another one of the academics at Monash, who's been an amazing mentor for me,
Yeah.
Duncan. Um, so it was really cool because both of these researchers were involved in that discovery, and obviously they knew since 2015, um, that there was this discovery, and that was a really cool moment. And so I think over the course of that semester, I decided that I wanted to work with these people and work in gravitational waves. And actually, now that I think about this moment a little bit more, I realized that another contributing factor was, of course, that Kip Thorne visited Monash in
Okay.
2015. This was
Okay.
before it was announced, and he gave a talk. Uh, Most of the talk I did not understand because I'd never done research. I went to both the public talk and the more specialist physics talk. I didn't understand basically any of the specialist physics talk, but I found it so cool. And I got the book signed like by Kip Thorne and everything. And yeah, that was a cool moment. So I think it was a combination of meeting Kip Thorne in person and then learning under two people really directly involved in the gravitational wave discovery that was
Yeah.
you know making me really interested in gravitational waves. And when it was announced, I was just like, wow, this is the coolest thing ever. The one that made an even bigger impact on me was, of course, the first binary neutron star merger, 170817, because I was working inside the collaboration at the time, so that was the coolest moment of research life so far for me.
Okay, that's great. And you can remember the names of these gravitational mergers like just by numbers. I saw you just, when you said 2017 and like that's so easy for you.
Oh yeah, sure. Yeah, I can. At least the big ones.
Okay.
Um, so I've been in the collaboration since 2017 at the LIGO collaboration. And at least the big ones I can remember off the top of my head. The ones that just got recently announced, because the
Yeah.
number of detections we make now is getting pretty big. So I can't remember the recent ones off the top of my head, but the big ones I can.
Okay. Yeah,
The
but
you
that's
know the
that's good. You can just
yeah
remember the names. Just remember the
yeah.
numbers too. So my next question is, even though you had already answered it in parts before, so has there been any significant change in your mental health, in past 1 or 2 years, like while you were doing research work in the pandemic? So anything specific that you would like to share?
In the pandemic itself.
Yeah.
So the way I do research, the way I work, um, um, it benefits a lot, at least to me. I'm not sure about others. It benefits from interaction with colleagues. I love talking science with people. So when we were in the office, that was quite easy because everybody was in the office. So I could chat with the fellow PhD students. I could meet an academic in the hallway. I could have coffee, and we could all chat. And people would come from overseas and give seminars in the department.
Yeah.
With the pandemic, all of that basically essentially stopped. So it was difficult to sort of adjust to that. um and that probably hurt my sort of, I wouldn't say it hurt like productivity or anything like that, because I found other ways to sort of keep at the same level, just you know increase the time I actually work rather than increase how effective I am. But the other thing that really hurt was, this was, as I mentioned before, right around the time that I was applying for jobs and things like that. What that meant was that I had to give a lot of talks in UK or US or European time zones or US time zones, and for Australia that means it's middle of the night. So I had to give talks at 3 a.m. or 2 a.m. or 5 a.m. Which what that meant was basically I was working nocturnally and
Yeah.
sleeping through the day, and that was that's never a good thing to do. So yeah, I think that was probably those two things probably the worst things.
So this question is related to your life, let's say your life at Monash University. So would you like to share any experience or any incident that has happened, throughout your PhD journey at Monash University, which was, let's say, something fun that you did not expect?
The best moments for me as a student at Monash, or just a PhD, doing a PhD in particular, were the moment the cool moments where you find something cool going on in the universe, or you think you have a really great idea that you want to discuss with your supervisor immediately, so you just go and knock on his door. Sometimes
Yeah.
don't even knock, it's open. So those moments are like the real highlights, um, and they happen frequently, especially when we were all in the office. uh, some other moments were, of course, an international person is giving a talk, and you go out to have coffee with them or anything like that, and you have a chat with them about some cool science for about an hour or 2 hours, and you forget about other work you had to do, but the science was so cool that you had an amazing day anyway. So those are the moments I think that I love personally. So yeah, hope that answers the question.
Yes.
Okay,
Yes,
awesome.
it is. Okay, so my last question is for our audience. Would you like to share any cool, space fact or something related to gravitational waves that can, let's say, maybe excite them and learn more about these things?
Okay. So a cool fact that always blows me away is, when you think about, for example, how much energy we use in a day or something. It's very tiny fraction of the amount of mass is used up. So if you're familiar with Einstein's, E equals mc squared, the famous formula, energy mass equivalence, if you convert basically uh, 1 gram of material, you get basically, what's that? I'm trying to do it in my head now. 10 to the 20 or so, which is billion
That's
billions,
way too big.
way too big. Exactly.
Yes.
If you convert just 1 gram, that's how much energy you have. You have tremendous amounts of energy. And so the thing that always blows me away is when GW 150914 happened, which is the first gravitational wave we ever saw. The amount of energy that was released in gravitational waves alone, there was about 4 times the total mass of the sun, um, amount of energy produced just in gravitational waves.
Yeah.
That's a ridiculous amount of energy.
Yeah.
So that's basically turning the entire sun and turning that into energy. So our sun, just four suns energy. It's
Yeah.
pretty incredible.
And that too in a matter of just few seconds, right?
That's right. Yeah, actually, that's a great point. Yeah, in a very very short amount of time.
Yeah.
Yep, absolutely.
And we're safe that that did not happen anywhere close. It's far away. Good for
Yeah,
gravitational
yeah,
waves. We
yeah,
do not wanted
definitely,
to see any
definitely.
electromagnetic waves or anything out of that. Would have been drastic.
No, yeah, absolutely,
Yes.
absolutely. Actually, that reminds me of a funny story, which maybe goes back to the previous question. Uh, One of the first projects I did, we found that to detect a particular type of signal from in LIGO, advanced LIGO right now, we would need something to happen basically inside our galaxy. And if that were to happen, we would be able to detect the signal, but the gravitational waves and the electromagnetic radiation would be so strong that we would probably be extinct. So let's hope that that never happens.
Yeah. Even though we want to see that, we do not want to see that.
Yeah, yeah, exactly. Yeah, even though I, would have been really good for my research project, but
Yeah.
probably not good for humanity.
Yeah. So I did not do that. I hope you found this interview very helpful. And one thing I can, guarantee students who are into gravitational waves, they can at least do, they can name dropping of the gravitational wave mergers like GW, dip, 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 and neutron stars. That's one
Yeah.
thing you can easily show off in front of your friends. But this was a very great interview. I got to learn so much myself, and I hope other students who are watching this, they also learn so much about what goes into life of a gravitational wave student. So thank you, Nikhil, for joining us today.